Sampling distribution of sample means. Before we start this important topic, let's talk about some basic stuff. So what we want to understand, what is the population? We have already done this in chapter number 1. What is the population? Just a review what we have done. This will help us, this refresher will help us in understanding the concept in this chapter. A population is, what is a population? A population is a collection of all individual or all items which are included in a statistical study. Let's say I want to know the average height of the students in my in the Berkeley College. So all the students of the Berkeley College will be my population. All the students, not any other college, because I want to, what I was interested in, interested in the finding the average height of the students in the Berkeley College. So all students of the Berkeley College will be the population for this discussion. What is a sample? A sample is a small part of the population. It has to be a representative. It has to be a representative, right? And it has to be a small part of that. So representative subset of the population, right? So such a small part of the population is called a sample. Now, these two concepts I explained in chapter number 2. What is a statistic and what is a parameter? A statistic is any numerical measure that describes some aspect of a sample. That describe an aspect of a sample. Look at that. This is a sample. What it can be? It can be a sample mean. It can be sample standard deviation. It can be sample variance. And it can be even sample proportion. We'll talk about this one also. So any descriptive measure that describes an aspect of a sample is called a statistic. And what is a parameter? A parameter is any numerical measure that describes an aspect of a population. For example, the population mean, the population standard deviation, the population variance, the population proportion. These are all numerical measures that belongs to a population. For this reason, these are called parameters. Okay, some commonly used statistic and their corresponding parameter. These notations are very important for the conceptual purpose. You must know the difference between these things. What is the difference between these notations? Because it will help you in understanding what's going on. For example, if we want to estimate the population mean, we use a sample mean to estimate. If we want to estimate the population standard deviation, then we use a sample standard deviation, right? And if we want to estimate the population proportion, we use sample proportion p hat. This is read as p, and this is p hat. It's written here, p hat. Okay. So I hope these concepts are very clear to you. These notations and these concepts must be very clear to you in order for a clear understanding in this particular chapter. Okay, what is the idea in the sampling distribution? What we do, we study samples to estimate about the population. That's what we do in inferential statistics. Okay, why we study sample? Why? What is the reason? What's not good about the population? Why we don't study the entire population? There is a reason for that. The most of the time, 99.9% time, our population is huge. It's large. We cannot access the entire population. Why? Because we don't have a time to do that. We don't have resources to do that. We don't have manpower to do that. So what we do, we restrict ourselves, and we restrict ourselves from the calculation, from the measurement, from the sample instead. So what we do in such cases, we use sample statistics, sample mean, sample standard deviation, and sample proportion to make inference. That's a word it's a word we need to understand. Inference, to make a conclusion, to draw a conclusion about something. What we do, we draw a conclusion about the population based on the sample, right? In such a cases, we use a statistics such as a sample mean, sample standard deviation, sample proportion to make the inferences about the corresponding population parameter like population mean, population standard deviation, or population proportion. Okay, now what we're going to do now in this example, we are going to see how we are going to construct a sampling distribution, right? In order to understand the concept, we have an example here. Suppose that the population of interest consists of 5 starting players on the men's basketball team, who we will call A, B, C, D, and E. Further, suppose that the variable of interest is the height in inches given by in this. We have 5 basketball players, names A, B, C, D, and E, and these are the heights of those basketball players. What we are asked to do that? We are asked to calculate the population mean. We are asked to obtain a sampling distribution. I will explain that, what is the sampling distribution and how you get that. Obtain the sampling distribution of the sample mean for a sample size of 2. And next we are asked to repeat the part B for the sample of size 4. We have done this B part for the sample size 2. Now he's asking to do the same thing for a sample size 4. So I ask you to pause this video and do the computation. At least you can do this one. Calculate the population mean. How you can do that? You add all these values and divide by the total number of observation. Pause this video and see what answer you get. So if you have done this calculation, the population mean comes out to be 80. Next, what we do, we obtain a sampling distribution of a sample mean for a sample of size 2. That's what we're going to do now. Let's see how we're going to do that. What we do, we find all the samples of size 2. So what I mean by the sample of size 2, we have 5 starting players. Let me write here A, B, C, D, and E. These are all 5. These are the names of the 5 players. And how I can select a sample of size 2, it can be AB, it can be AC, it can be AD, it can be AE. Then it can be BC, it can be BD, it can be BE, it can be CD, and it can be CE, and it can be DE. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are all samples of size 2. Sorry for these lines, it's coming automatically. These are all the samples of size 2. So from out of these 5 players, these are all samples of size 2. Let me show you the pic. Look at that. These are all samples. These are all samples of size 2. Look at that. Look at that. AB, AC, AD, AE, BC, BD, BE, CD, CE, and D. These are all the samples of size 2. What I have done in this column, you have to pay attention how I'm getting this one. What I have done, I have written the heights of these players. This 76 is the height of A, and 78 is the height of the player B. And what I have done here, I have added these two values and I have found the mean. So this is the mean. This is the mean. This number 77 is the mean of this one. This is the mean of these two values. 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 This is the mean of these two values, and so on and so forth. So what you recall, what you can think, a new variable is generated. Look at that. A new variable is generated. A new distribution, a new column. We have a given birth to this calculation has given birth to a new column, and I'm calling this column as X bar. Why? Because it's a sample mean. So it's this column. This is the what I have encircled. Excuse me. This is what I have encircled in red. A new column is generated. A new column is generated, and this is the column. We call it as the sampling distribution of sample mean. I call this column, I call the sampling distribution Of what? Of sample means. This column we call as a sampling distribution of sample mean. Look at that. Note that our population mean, recall that our population mean was 80. Okay, from the previous slide, I hope you remember that. Note that some of the means are below 80 and some of the means are above 80. Look at that. This is below 80. This is below 80. This is also below 80, right? This is also below 80. This is above 80. This is below 80. This is below 80. This is above 80. This is exactly equal to 80. This is above 80 and this is above 80. Note that some of the values, some values are below 80. This is a population mean, and some of the values are above 80. This is what we call it, this behavior. We call this behavior that the sample mean targets the population mean. That's this behavior we call, in a technical term, we call this as this behavior that the sample mean targets the population mean, or we can also say the sample is a good estimate for the population mean. Okay, that's what we say. Now we repeat the same. So what I ask you now, what you do, you add all these values. You add all these values. I'm talking about these values. Please add all these values and divide by the number of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pause this video and add all these sample means and divide by the number of values. See what you come up with. So if you have performed this calculation, you would have obtained the same answer. You would have obtained the answer as 80. It's the same value as that of the population mean. This is the same mean for the population mean. Let me represent this by a notation. I'm calling as the mean of the sample mean. Look at this notation. We call this a mean of the sample mean is equal to 8. And what happened actually, we found the mean of the sample mean turns out to be the population mean. We will talk about more about this later in this video. Let's go further. Now what we do, we repeat the same process. We repeat the same process for what we have done previously. Previously we have done for the sample size of 2. Now we do the sample size 4. So these are all samples of size 4 and these are 5 of them. And what I have done here, I have written all the heights here, right? These are the heights. These are the heights. Now what I have done, I have added all these values and I have divided by the number of observation 1, 2, 3, 4, and I have computed the mean. A new column is generated, and that column, this column is called the sampling distribution of the sample mean. So I ask you guys to pause this video and find the mean of these values also. Add all these values and divide by the total number of observation, and let's see what answer you come up with. So if you have done this computation, you will be surprised to note that the answer comes out to be, sorry about that, the answer comes out to be the 80, right? If you add all these values, the answer comes out to be, mu comes out to be 80, right? Let me call this as a mean, the sampling mean of the sample mean, a mu of x bar, which mean, yeah, I'm talking about the mean of the sample mean, and this comes out to be the population mean, right? We have done the same previously, the same thing, right? Now let's see what else we have. Now we are in a position to define what is the sampling distribution of the sample mean, right? So what we have here, sampling distribution of the sample mean. Let us suppose we have a variable x and a distribution of variable x bar. The distribution of the variable x bar is called the sampling distribution of sample mean. In this chapter, these three phrases are the same: sampling distribution sample mean, or the distribution of the variable x bar, or the distribution of all possible sample means of the given sample size. These phrases have the same meaning. They are considered the same. So it's very important that you understand this one, these three things: sampling distribution sample mean, or the distribution of the variable x bar, or the distribution of all possible sample means of a given sample size. We therefore use these three terms interchangeably. So I hope you understand this basic preview. And now we'll talk about a very important term called central limit theorem.